designated speakers and esteemed panelists. I'm really thankful to you for providing us with the valuable time and finding time to be on this particular webinar. Before we move ahead, I'd like to tell you about the agenda of this particular webinar. So as you can see, this webinar will be running for 1.5 hours, and it will cover 2 presentations and would be followed by a panel discussion. Before we proceed with the webinar, I would like to cover some housekeeping rules so that the webinar proceeds in a systematic way and you can get the most out of it. The event would be live streamed on WRI India's YouTube channel and recorded for documentation purposes. The participants joining online must keep themselves on mute when not speaking. Kindly use the question and answer box for queries to the speakers. Our speakers will try to answer some of them in the session. The moderator may pick up few questions at the end of the discussion and will pose it to the panelists. Kindly use the chat box for any technical issue, queries, and comments. For feedback, please drop us a mail at indiaenergy@wri.org. And all our updates will be on the WRI India Twitter handle and WRI India's LinkedIn page. Let me thank you once again for joining today's webinar titled Industrial Decarbonization. Are the industries ready for green hydrogen? This is part 1 of the series of webinars we will be conducting to touch upon the industrial decarbonization. To take you through as to why we are talking about the industries in this particular webinar, the industrial sector holds a prominent position in the Indian economy, accounting for about 31% of the GDP. The industry's relevance can be identified through various direct and indirect linkages with other sectors, contributing to economic growth and employment. However, the sector is also responsible for a significant share in the carbon emissions for India. In the year 2019 alone, the carbon emissions for India was dominated by the burning of fossil fuels for electricity production, and was closely followed by the industrial production of materials. With India's pledge to reduce the emission intensity of its GDP by 45% by 2030, industries must prioritize decarbonization. With the announcement of National Green Hydrogen Mission and the decarbonization of industrial, mobility and energy sectors, and reduction in dependence on imported fossil fuels and feedstock can be addressed. The focus on several hard-to-abate sectors where green hydrogen can be used to significantly reduce the emissions, including iron and steel, cement, fertilizers, and refineries, will certainly require special emphasis in terms of development of policy and standards, ancillary industries, addressing challenges, and provisions of financial support. This webinar is organized as part of the Clean Energy Technology Hub. The objective of this hub is to enhance knowledge, gain valuable insights, and accelerate the clean energy transition with panel discussions from industry leaders and government stakeholders on all the latest trends and developments in renewable energy, challenges and opportunities, and case studies. We begin today's webinar by a presentation by Lalit Sharma on why green hydrogen. Lalit is our Senior Project Associate with the Energy Program at WRI India. He's working as an energy efficiency professional with the knowledge of working across various dimensions of energy efficiency improvements in the industrial sector and supporting transformational projects. Lalit is an electrical engineer with BTech certification from Punjab Technical University, Jalandhar. He holds a 3-year diploma in electrical engineering from PSBT and IIT, Chandigarh. Over to you, Lalit.
Yeah, thank you, Abhishek. I'm audible?
Yes, you are.
Yes, you're audible.
So I'm just sharing my screen. Thank you, Abhishek. Hello and good evening, everyone. So I will provide a short presentation on how industries' emissions are required to be reduced and how the green hydrogen will help for the industries. So as we all know, India has set their target become net zero by 2070. To achieve this target, industry has to take a step towards green hydrogen. As per Global Carbon Project report in 2021, India contribute almost 7.5% of the global emission. If we look India emissions, then the energy sector contribute approximately 53% and industrial sector contribute 25% of the total emission. More focusing on industrial sector, almost 60% contribution is from steel, cement, chemical, and fertilizer sector. So basically focus on steel sector. So Indian steel sector is playing a very important and significant role in India's economic growth and development. Indian steel sector is the second largest crude steel producer after China. So India is a developing country and the infrastructure projects are continued ongoing. And with this, the demand of steel is increased by 2030 and it will be doubled by in 2030. So total emission in India's steel sector is around 250 million ton of CO2, and with increasing in demand and continue with the old technology, it will be reach around 800 million ton of CO2 by 2030. So basically, there are three routes we are using to produce steel. So that is blast furnace route, electric arc furnace route, and induction furnace. So 45% production is produced by the blast furnace, and in 2016 that is 43%, which is increased by 2% in 2021. And the blast furnace route is the most emitting sector. If 100% green hydrogen-based production can be produced, then about 90% emission can be reduced. According to a case study from the Q, designing a green hydrogen project, green hydrogen direct reduction iron and electric arc furnace with the capacity of 0.5 lakh million ton of 0.5 lakh million ton of hydrogen capacity, it requires 470 megawatt of renewable energy and 210 megawatt of electrolyzer capacity. So this is the emission in CO2. It will reduce to 0.25, which is 2.3 with the blast furnace. But it takes time, as we can expect by 2040, 100% green hydrogen blending with the steel sector. So coming to the cement sector, so Indian cement sector is the second largest sector in the production after China and the third largest industrial energy consumer. In 2018, the emission from cement sector is around 149 million ton of CO2. In this given table, you can see Indian cement sector is already very efficient with the world average, where world average energy consumption in cement sector is around 100 to 110 kWh per ton of production and 850 to 860 kilocalorie of kg of clinker, where India stood at 82 kWh per ton of production and 725 kilocalorie of kg of clinker. As green hydrogen has a limited use in producing cement, so might be CCUS method has a huge potential to reduce emission in cement sector, and the CCU is the different topic to discuss. Might be in our next webinar, we will discuss on CCU. Coming to the fertilizer sector, so India is the second largest producer consumer of the fertilizer in the world after China, and it's close about 15% of the global share market. So as per the Ministry of Environmental, Forest and Climate Change, the total emission of fertilizer sector is around 43 million ton of CO2. Like cement, India fertilizer sector is also less emitted sector than China and Europe. So today ammonia is produced using green hydrogen from fossil fuel. To produce green fertilizer, the hydrogen needed to make ammonia will come from water using electrolytes based on renewable energy. So what is green hydrogen? So green hydrogen, the hydrogen that is produced is considered green because it's created without the use of fossil fuel and produce no greenhouse gas emissions. And why green hydrogen is important? So green hydrogen can play a crucial role to decarbonize energy intensive industries such as steel, cement, chemical, and transportation also. So green hydrogen produced from renewable source such as wind, solar, hydro, make it clean and sustainable energy source that produce no harmful emission or pollution. So talking about the national green hydrogen mission, so on 4 January, India 4 January on 22, the Indian government approved the national green hydrogen mission. The target of this mission is to produce 0.5 million ton of green hydrogen per annum by 2030. The need of this mission is to, of course, the net zero by 2070 and reduce the dependence on the fossil fuel, of course, and achieve the nation RE targets. The target is also to make the India global hub of the green hydrogen and also make India leader in technology and manufacture of electrolyzer. To achieve these target and challenges, there are some challenges like cost of green hydrogen, infrastructure of green hydrogen adoption, and lack of harmonized standards and regulation across the world. So green hydrogen mission will start in two phases. So phase one is already started and it will be ending in 26, and the second phase will be ending in by 2030. The government of India has also announced 90,000 crore for the green hydrogen. So hopefully this amount will utilize for the R&D and the pilot project for the green hydrogen. So with this, I'm ending my presentation, and a few questions like, what is the solution for the industry to adopting the green hydrogen, and how this amount can be allocated and help the industry to adopting the green hydrogen. So thank you very much, and over to you, Abhishek.
Thank you, Lalit. Thanks for that wonderful presentation. Now moving on, we have our next presentation by Mr. Mukesh Kumar. Dr. Mukesh Kumar is working as a senior advisor to GSPL Group to spearhead green transition and decarbonization of the existing operations for achieving carbon neutrality. He's also involved in various diversification plans, expansion of existing operations as well. Before joining GSP Advisory Group, he has served as Director, Steel Research and Technology Mission of India SRTMI and contributed to the technological development as well as driving green steel agenda. He is having more than 4 decades of experience in metallurgy, oil and gas, technology development, and project management in India and abroad. He was expert member in various committees of the Government of India like coal to hydrogen, coal gasification, e-waste management, resource efficiency, and circular economy in mining and metal sectors. R&D committee for Ministry and Steel, Ministry of Electronics and Information Technology, and other R&D solutions. We thank you, Mukesh ji, for joining us. Please go ahead with the presentation.
Abhishek, can I start? Can I share the presentation?
Yes, sir. I think you can share your presentation.
Can you see my presentation, Abhishek?
Yes, sir. We can see your presentation.
Good afternoon to all the participants in this important conference, that is industrial decarbonization. Are industry ready for green? And particularly, I will try to touch about the solutions and the challenges in the steel industry. Because steel industry, as Lalitji has told very distinctly, that fertilizer is contributing around 43 million tons. Cement also is contributing, but steel is one of the largest contributors of the green steel. Although global is around 7%, but in India, it is contributing around more than 12%. If we see in India, because we are generally following 3 types of. One is the route, which is very common, around 55 to 60% of the steel is produced by iron ore using coal, and the bottom is known as the blast furnace. The second route, blast furnace route, is more common because we have large reserves of iron ore and most of the ores are high. Second thing, the main problem was India is not having rich natural gas resources available with us. So we are totally dependent on external sources. India, second point is India is a young economy. And
Sir,
because of the young, hello?
Sir, I'm very sorry to interrupt you. Your voice is a little less audible. Can you speak on the mic?
Just a minute.
Yes, sir.
Can you hear me now?
Yes, sir. It is much clearer now. Please go ahead.
Okay. Sorry for the inconvenience.
No worries, sir. Please go ahead.
And third point, what I was impressing is that scrap availability in our country is also very, very limited because we are a young economy and the recycling business or recycling of steel is yet to be developed, because normally life of steel is around 50 to 60 years. So if we see from that angle, we may get some scrap availability after 2040-45, but right now availability is very, very low. And globally also, because every country is trying to move towards the scrap base, because decarbonization is one of their main agenda. So availability of the scrap in international market is squeezing, and at the same time, price is also increasing. So the only option left with India is to try to use their internal resources, and that is iron ore or coal, and use blast furnace technology. So this is a general how India is doing this thing here. Now, coming to our this thing, as Abhishek also has told, Lalitji also has told, steel is considered as a hard to abate sector. Why we say is a hard to abate sector is mainly because of the two reasons. There is no immediate alternate technology available by which we can start making steel. Although a lot of research is going on, hydrogen is being considered as one of the substitute. Other technology also like electrolysis are coming, but all are in nascent stage. And in steel making, whenever we do any research, it is capital intensive, it is time intensive. It takes at least 10 to 15 years to get any new technology to come into operations. So right now, we don't expect that anything is available by before 2035 or 2040. So anything can be available after, but till that time, our requirement is increasing. We are one of the lowest producer of steel, lowest capital per capita consumption of the steel, and our demand is continuously increasing. And today we are producing around 120 million ton of steel. It is expected to go around 250 million ton by 2030. That will require a capacity of around 300 million ton. Going further, if we go to 2047, it will be around 400 million ton requirement, means capacity will be 500. So only India is having two options, either to stop increasing capacity based on the existing technology or import the steel. Import is not a substitute. If we have to meet our internal demand, the only option left is our blast furnace and BOF for the time being. And parallelly, we go on trying alternative. But in this technology, emission is high. So we have to see how to meet international expectation also of becoming one of the lowest CO2 emission producers. And at the same time, we should meet our internal demand also. Today, if you see in India, our per ton of steel, CO2 generation is coming between 2.5 to 2.8 ton per ton of crude steel. And if you see from the India point of view, India is making around total contribution in this field is around 10 to 12%, because total our emission is around 3.4 gigatons. And out of 300 gigawatt today, we are emitting more than around 320 million ton of carbon dioxide from our sectors. So there is a need that we have to meet our expectation of 2-degree temperature rise. So we have to take action in a way so that we remain competitive globally also. At the same time, we are sustainable. So when we are attacking these things, we have to keep in mind that we should attack all three emissions. Whether it is direct emissions, means coming from our production, like scope 1, which we call it, or it is coming from external source of energy like electricity and other things, which is coming from indirect. And third is our other indirect like transportation of the iron ore, transportation of the coal, transportation of your rail product and other things. So everywhere opportunities are there. So where we can enter. So those things we have to attack in all the directions. As I mentioned, right now, no much technology is available. So the green pathways options available with us is either whatever best available technologies are there, we should try to make use of this. Second thing, like from starting from mineral beneficiation to use of natural gas and other things, and other best, wherever any heat loss is there, we should try to recover that. It can help us in reducing our potential by around 25 to 30%. And that is the phase one, which we should target by around 2030. Second thing is maximizing scrap-based production. In time to come, because of various initiatives like vehicle scrapping policy and other things, our scrap availability is likely to increase. And when we will start coming this thing, and you start using renewable power, then we can get another 10 to 20% there. But the major part is how to achieve carbon neutrality. And carbon neutrality where hydrogen is going to play a major role. Because hydrogen is one of the fastest and best reducing agent for iron. Other options also we have to see what this carbon capture and utilization is there. Those also we have to see, and other. So I think once we attack in these three directions, we will be in a position to achieve our carbon neutrality by 2070, what our Honorable Prime Minister has committed, and we all are working towards that. So now, if I present in the format of this thing, that first step is best available technology, we will achieve around 20% reduction in our this thing. Going further scrap, another 20 to 30%, and last three will be around carbon neutral. With this, because we have to see that globally also, how the demand is increasing, because demand is also becoming stable worldwide except Asian regions. And if we start adopting this thing, we feel we will be in a position to meet our decarbonization this thing, status. As I already explained, we are targeting around 510 million ton capacity by 2050. And if you see, the major contribution will come from the building, from the infrastructures, because these two will remain our major consumer. So in this, other than this decarbonization, we have to see the material efficiency part also, so that like country Japan and other things who have started using high strength steel, and what they are doing is they are trying to minimize the use of the steel. When we are saying minimize of the use of steel means using steel, but with less weight. And when with less weight means high strength material. So that will also help us in achieving our decarbonization potential. So if I give you my NDC status today, in 2005, our emission was around 3 ton in primary sector, means blast furnace and other. And in secondary sector, it was 3.2. But 2020, our target was between 2.4 to 2.6, and here it was 2.8 to 2.9. This 2.4 to 2.6 we have achieved. Some company has achieved even better than this. But the problem is coming the emission. Total emission, what we were expecting, it is around 216 to 234 million ton. But today, how much we are making from all these sources? It is going beyond around 320 million ton, 330 million ton. Because every ton we are generating around 2.6. So 120 into 2.6, it gives around 300 to 310 million. So this is a challenging. Initially, we planned that we will reduce to 2.2, 2.4, but recently under Ministry of Steel, Green Steel Vision, we have further revised this potential. And now we are targeting that we should try to achieve below 2, so that we are on the track by 2030. So if you see the global picture, if you see the crude steel demand and scrap availability, because most of the countries are working on scrap availability, if you will see from 2020 to 2050, whether it is Europe, whether it is Middle East, whether it is CIS country, Japan, and everywhere, you will see that most of the places either demand is becoming stable or scrap availability is increasing. It means they will be very easy handle decarbonization by using renewable energy. But if you see in Asian region, the demand is also increasing and scrap is not increasing to that extent. So India and Asia particularly will remain a major challenge how to handle this thing here. So this is just this thing. If we continue our right now, today we are producing around 1.8 billion ton of steel. And if we would have continued this thing, it would have gone to 4.3. But since we are started recycling and other things, we feel that by 2050, we will be in a position to meet our demand by around 2,300 or 2,500. So once we are around 2.3 to 2.5 here, emission which could have gone to around 4.3 gigaton globally, we feel it will come down to less than around 2 gigaton, means 1.5, 1.6 by 2050. And then 2050 onwards, again, we will go and we will try to achieve carbon neutrality by 2070. So what are the pillars for decarbonization we have? So our pillars are, one is carbon dioxide minimizations. And in this case, like we are going for coal gasification, resource optimization, use of pellet, high grade materials should be used so that our emissions is reduced, our raw material requirement is reduced. Second is our CO2 avoidance, where we are trying to use scrap, then heat recovery from various of gases, use of renewable power, and maximizing hydrogen in this. Another thing is what will happen is that if we can adopt, like we are doing metal recycling, can we have a carbon recycling? And when I'm saying carbon recycling means we should convert carbon dioxide into carbon monoxide. We should and use it back into the steel making, converting carbon dioxide into syngas through co-electrolysis of carbon dioxide and steam and use it. And then last is dry reforming of carbon dioxide. Instead of the steam reforming, should we go for dry reforming with CO2 so that syngas is produced and again we use? If we can bring focus on carbon recyclability, I feel we will be in a position to achieve our carbon neutrality goal much before than 2070. Although other options are also available with us, that is utilizations, like converting into bioethanol, because India is having a huge requirement of bioethanol. And this carbon dioxide with green hydrogen can be easily converted into bioethanol, and we can meet 100% requirement, and even we can become one of the export country for bioethanol. Methanol also people are looking, but economics wise, it is not giving that advantage. And other options are like make crude algae and biodiesel and sustainable aviation fuel. But this technology also is going to play a major role for the steel sector, because steel sector may have to diversify along with carbon recyclability and carbon utilization, I think, and maximizing using of hydrogen, we will be in a position to achieve our carbon neutrality much before that. So these are some of this thing, like syngas, natural resources, and recovery of bioproduct. It will attack all these things. Scope 1, Scope 2, Scope 3. Like today, most of the companies are working on transportation of iron ore by slurry pipelines that will reduce CO2 emission drastically. Then recycling within the mass only, recovering byproducts, all those things will come. This is one of the example how CO2 will be converted into CO. And that CO, so like Jindal Steel and Power Limited is working with IIT Bombay, and already laboratory study and everything has been done. And we feel that by end of this year, we will be in a position to establish proof of concept and start going commercialization of this. If this is successful, I think this will help to reduce our emission by more than 20 to 30%. Similarly, number of companies have come, Helder, Topso, Lanjatech, Christopher. Like Jindal Steel is talking to all these companies for utilizing these things, because Jindal Steel has taken a target that we want to become carbon neutral before 2040. Our intention is to become 2035, but definitely by 2040 we want to achieve. So that's why we are trying to explore all these options also. Hydrogen, coming to the hydrogen, I don't say that hydrogen is one of the best, but whether India is ready for hydrogen. Today, if you see, these are the two routes, blast furnace route and hydrogen route. In hydrogen route, we have to have an energy, that is renewable energy. 1 kg of hydrogen requires 55 units of electricity. And 1 ton of steel making requires around 70 kg of hydrogen. It means for producing 1 ton of steel, I need minimum 400 to 500 units of electricity against what I am doing presently, nothing. So the power requirement, like today for a 1 million ton plant, I generally have a power plant of 60 to 65 megawatt. But if I go with a hydrogen-based steel making, I will have to have a power plant of minimum 550 to 600 megawatt. It means nearly 10 times increase in power required. Another reason why it is coming so, because hydrogen reduction of iron ore is an endothermic reaction. So it is not only hydrogen production, it is heating of the hydrogen to a temperature of around 1200 to 1300 degree temperature, so that when we are working, we can close. So hydrogen, other technology advantage also there, electrolyzers are not there and other things. So I feel hydrogen is a good opportunity. Slowly and slowly we should try, but we have to see during this time, other than hydrogen, we should attack other areas. So because right now, whether we are ready for green transition or not, today cost is becoming prohibitive. Today, if you want to, I will take another 2 minutes and close it, sir.
Sir, sure, sir, sure.
And it is going around 180% increase in the capacity. That's why people are thinking. But like Abhishek has told, a lot of incentives are being given by the government under hydrogen mission and other thing. And we feel we will be in a position to utilize those incentives and go ahead with this. So this is generally a path, how we will accept on the pathways, process, integration, and initiatives. So with these three things and circular economy in focus, I think India will achieve carbon neutrality by 2007. So I say decarbonization study may influence my future growth of the steel. And hydrogen can be an option, but requires large R&D to address technical challenges and minimize cost of production. So with this, Thank you very much. And I feel steel industry will definitely come forward and see that the challenge given to us is met. Thank you very much.
Thank you, sir, for that enlightening presentation. I think the various perspectives covered by you, including the adoption of the decarbonization of iron and steel in the Indian segment, and the way you brought about the whole world context. I think the various technology adoption measures, the new technologies that might be coming up, I think that provided a good outlook of all the decarbonization ways in the iron and steel sector. And I'm really thankful for this presentation. Moving forward, we will begin with the panel discussion of 50 minutes for now. To introduce you with the panelists, I will go one by one. Our first panelist is Mr. G. Siva Ramakrishnan, who is the fellow at Fellow Energy at WRI India. Mr. Siva Ramakrishnan is an electrical engineer with over 3-decade-long experience starting from 1989. He continued in project management of electrical jobs till 2003. He was with GE then. After 2003, Siva turned to entrepreneurship in solar industry. He developed many solar power plants during this period. He started serving the industry as an engineering consultant from 2015 onwards. Later, his expertise was utilized by government agencies in their programs. He served as advisor of nodal agency for solar energy in his home state, Kerala. Besides, he served the policy think tank State Planning Board in its energy working group. He functioned as a governing council member in Solar Energy Society of India, which is the Indian section of Indian Solar Energy Society. We welcome you, Mr. Siva Ramakrishnan. I would request you to please switch on your camera for our audience. Moving on, our second panelist is Dr. Gunja Munchal, who's working as a manager for hydrogen team in the Sustainable Cities and Transport Program at WRI India. Based in Delhi, she looks after projects related to hydrogen production, storage, and regulations. Prior to joining WRI, Dr. Gunja was working as a scientist at National Thermal Power Corporation Energy Technology Research Alliance, which is a research and development arm of NTPC. She worked in different projects related to hydrogen production via electrolysis and gasification, hydrogen storage, and compression systems using metal hybrids. Torrefication and quantitative and numerical analysis of biomass co-firing in thermal power plants were also an area of interest. Dr. Gunja completed her doctorate from Chemical Engineering Department, IIT Delhi. We welcome you, Dr. Gunja. Our third panelist is Mr. Nishant Balasubramanian, who is the Indian representative at Green Hydrogen Organization. Nishant is a highly accomplished professional with a diverse background spanning the automobiles and renewable energy. He has been associated with leading companies such as Honda and Ford. Currently, Nishant is focused on combating climate change through his role as India representative for the Green Hydrogen Organization in Geneva, Switzerland. Green Hydrogen is a registered Swiss non-profit organization launched at the UN General Assembly in 2021 with a mission to accelerate the adoption of green hydrogen to reduce carbon emissions from other energy sources and forms of hydrogen. We welcome you, Mr. Nishant. Our fourth panelist is Dr. Pooja Devi, who's working as a principal scientist at Central Scientific Instrument Organization, Chandigarh. Her major research interest is in the domain of sensor and catalysis for energy and environment with a focus towards green hydrogen production, water-air pollutants degradation, and water pollutants monitoring. She's working towards developing new materials, studying their fundamental properties, and addressing their techno-commercial aspects and possible integration with commercial products in the above domains. She has published around 87 research papers in high-impact journals, 6 peer-reviewed conference proceedings, edited 7 books as leading editor, and published 23 book chapters. She has also filed 3 patents, 2 design registration, 2 copyright trademarks, and developed 4 technologies, 2 of which are transferred to the industries. She is currently serving as a core committee member of the Indian Young National Academy of Science in SAS, New Delhi, and GC member of the Electrical Chemical Society of India. We welcome you, Dr. Pooja. Our fifth panelist is Mr. Prerak Thekadi, who is the head of technical and electrolyzer at Adani New Energy Industries. Mr. Thekadi has 20 plus years of experience in business transformation, market analysis, sourcing strategy, business opportunity analysis in various countries, risk management, sustainability perspective, merger and acquisition, and vendor management. He achieved a place in top leaders under 50 and was awarded as the leadership and business excellence by EQ in 2022. He was also awarded second position as Outstanding Procurement Future Leader and Conference Asia during Chief Procurement Officer Award Ceremony in 2018. He has been invited as a speaker and represented Adani Renewable and Adani Hydrogen business in various forums as a speaker. He also achieved a place in competition of 40 under 40, India's 40 most promising young business leaders in the solar industry. And our final panelist is Dr. Mukesh Kumar, who spoke earlier today. As for the moderator, the panelist discussion would be moderated by Mr. Sripati Anurath, who is the project associate at WRI India. Sripati's primary area of work revolves around new energy technologies, focusing on upcoming green technologies to achieve a smoother clean energy transition across India. Prior to joining WRI India, Anirudh completed his MTech in Energy Studies from Indian Institute of Technology, Delhi. There, he worked on a solid-state hydrogen storage system and solar radiation prediction modeling. We welcome all the panelists on this particular platform. As a reminder, we would suggest to kindly use the question and answer box for queries to the speakers. Our speakers will try to answer some of them during the session. The moderator may pick a few questions at the end of the discussion and pose it to the speakers. Over to you, Sripati.
Thanks, Abhishek. I hope to the panel members, my voice is audible.
Yes, your audio.
Okay, thank you. So good evening, everyone, and thanks to the experts for their time taking part in this session. So this roughly 45-minute session, we will be focusing on industry's preparedness towards adopting GH2 and the current hurdles and support that may be expected in form of policy and what should be expected. So first, when we are starting with the hydrogen adoption, the initial problem is hydrogen production cost, as rightly stated by Mr. Mukesh sir during his presentation. So this is one thing, and another thing is India is also focusing on becoming an electrolyzer manufacturing hub as a global hub for electrolyzer manufacturing. So let me start this with Dr. Pooja Devi. So what are the kind of R&D activities that are taking place in our country, particularly from CSIR's perspective, towards minimizing the cost of green hydrogen production?
Thank you, Sripati. Thank you, team WRI, for first of all connecting me and giving me an opportunity to speak on this platform. So likely, like most has been said by previous speakers, and India is committed to reach carbon neutrality by 2070, and green hydrogen mission is a part of it. And we all know that Minister of Power recently even launched a green hydrogen policy on February 17, 2022. And if we see in terms of the commitment of India towards green hydrogen mission, one of the contribution is coming from this manufacturing or required to be coming from the electrolyzers manufacturing. And as effort from Government of India side, out of the 19,744 crore layout, which is let down for green hydrogen mission, around 17,490 crores are allocated for the supply side incentive for electrolyzer manufacturing and green hydrogen production in India. And in this, around 400 crore has been earmarked for the R&D program only. So in the R&D program involves it includes the efforts from the CSIR, from the DST, and from MNRE. So these are the organizations which are involved in the R&D programs in this particular line. And if we talk about especially the efforts from these three different organizations, like DST under Clean Hydrogen Mission, innovation is setting up identifying the cluster, Hydrogen Valley clusters by 2030. And CSIR is basically has started the Hydrogen Technology Mission Program with focus towards improving the lifetime of electrolyzers technology existing in India, and also develop the supply chain components for the electrolyzers. So that includes different components like thermochemically robust membranes, electrolytes, reinforced different kind of bipolar plates or ceramic interconnects. So these are different components which are required in electrolyzer technology to make it, right now, we have a capacity to produce hydrogen of megawatt. And if we want to reach a target of 2030, we need to have a technology which can produce the hydrogen up to a level of gigawatt. So the indigenization of component storing the supply chain is also an important part, which under R&D, different labs, including CSIR, is taking effort. And there are other institutes like MNRE is also putting a lot of effort in this particular direction. And the incentive for the electrolyzer manufacturing is being given by the government of India to encourage manufacture to set up the dedication production facilities in India, so as to increase the economies of scale and further reducing the cost of electrolyzers. And pilot projects are being developed in the ecosystem where the end use take place in close proximity to the production site. I agree with the previous speakers that the cost of hydrogen production, especially green hydrogen, is high. But India has a distinct advantage in terms of the low-cost renewable electricity, which can complement the rapidly falling this electrolyzer prices, which can enable green hydrogen to be not just economical compared to fossil fuel-based hydrogen, but also compared to the green hydrogen being produced around the globe. So the cost of hydrogen production from electrolysis in India is around $7 per kg to $4 per kg, depending upon what technology is being used. But it is expected to come down with the kind of availability of renewable energy in India and the low cost of electricity in India, and Government of India efforts in giving incentive to manufacture electrolyzers, as well as R&D efforts for the indigenization of this technology, including the supply chain components.
Understood, ma'am. Thanks, ma'am, for the detailed answer. So let me just go to Mr. Prerak Tekadi as well. So again, this is from a from a perspective of a green energy firm involved with the interactions from the initial off-takers of hydrogen, mainly fertilizers and refineries. So there is a need for establishing, it's a competitive environment currently on the scale of cost of hydrogen. So how is Adani Green Energy looking at it as an opportunity, and what are all the R&D activities that Adani Energy is working towards cost reduction of electrolyzers?
Okay, first I will start with thanking WRI for arranging this session, which is this green hydrogen is the future for the energy sector. And if you want to make energy sustainable, the green energy or green hydrogen is the only option to make it sustainable. So thank you so much for arranging this. About the question which you have asked, the green hydrogen development is the more focused area in today's world, because if you want to make it sustainable, first you have to bring down the cost of the green hydrogen, and the 70% of the green hydrogen cost is coming from the green energy. So that means if you want to have a large manageable scale of the green hydrogen, we have to bring down the cost of green energy, which is contributing 70% of the cost in the hydrogen. That is one. Second point is about the electrolyzer. Electrolyzer and electrolyzer technology and its sustainability on a green energy is a big question in the world, because it's a new technology, not proven on a large scale in any part of the world. We have to be very much conscious on a selection of technology. Right technology should be selected and it should be utilized in the right forum. So the enough research and development process is required to make it more sustainable. The green, the ammonia, urea, and other part is coming as a downstream of the hydrogen business. So if we consider the hydrogen business, it starts from the green energy production to that green energy transportation from that energy source to the electrolyzer. Then the electrolyzer will generate the hydrogen, and then hydrogen would be used for the downstream, just like ammonia, urea, and ethanol, methanol, or any other energy sources. It can be used for the steel and fertilizer industry. To make it viable up to that industry, even if for 15% or 10% up to the extent, if we want to make this compulsion that this fertilizer and steel industry has to use 15% of the green hydrogen, then first we have to either bring down the cost of the green hydrogen or have to utilize the different subsidies. Now, if we consider in today's scenario, even if government will give or issue a good subsidy, but is there a readiness for development of this green hydrogen in today's scenario? No, the readiness is not there, because to make it readily available, we should have enough electrolyzer technology, electrolyzer manufacturing capacity, and green hydrogen manufacturing capacity. So it's just like a chicken and egg question, that whether the policy should come first or the developer should take the first initiative to develop the green hydrogen. can being a part of the one of the largest conglomerate of the India in infrastructure part, we can say that green hydrogen is a need of tomorrow. Definitely, it should be made it as a part of policy decision, but the first and foremost should be we have to focus on the electrolyzer technology and the policy which can be more easy for generating the green hydrogen, just like land for green energy, just like a transmission part, just like a power bank we have to use, where the generated green energy can be utilized for the hydrogen and the transportation facility should be managed. Then we can able to give a good room to the green hydrogen. Beyond that, it also required a huge requirement of water to generate the green hydrogen. So the place where we can establish the plant, not necessarily water sources nearby available. So this type of challenges we have to overcome to take this green hydrogen on a large scale.
Thanks. Thanks, Mr. Prerak. So from the key takeaways from based on the answers received from Dr. Pooja and Mr. Prerak is that the cost of green hydrogen is still a concern and the readiness depends on the infrastructure of electrolyzers and related green hydrogen infrastructure. We will take these inputs and this will be brought back during the second stage of our discussion. So moving on to the industrial preparedness, let me again get back to Dr. Mukesh Kumar. Sir, in the presentation, you have made it clear that green hydrogen will play a part not any sooner, and your focus is on the efficiency enhancement of the existing technologies. So with that said, and you also mentioned that by 2040 or even by 2035, you wanted to Jindal wants to become a carbon neutral organization. So even for becoming a carbon neutral organization, you currently feel that green hydrogen won't be playing a part in this part in your roadmap?
Yes. As I mentioned, whether we go with a carbon recycling route or whether we go steel making route, because unless we go for a carbon utilization also, green hydrogen is going to play a major role. So right now, because our main problem is the technology for hydrogen based production is in the nascent stage. Yes, we can use some hydrogen, but hydrogen, as I mentioned, it is an endothermic reaction. So people are making various trials, how much hydrogen we can add. If we say today whether any technology, commercially proven technology is available, where 100% hydrogen can be used, I will say no hydrogen technology is available today. Because maximum one plant has been completed in Sweden, that is only 1 ton per hour, means 24 ton per day. If no trial has been taken on a level of 2 million ton or 2.5 million ton or 3 million ton. So that will take time. That's why I mentioned up to 2030-35, we can start blending hydrogen, and in that direction, we are working. Like JSPL has taken a lot of initiative. We are setting up our own renewable park. We are setting up our solar center, and those solar centers will be using for generating hydrogen. In Oman, we are the company who has declared to become the first company in the world to set up a 2.5 million ton green hydrogen based steel making with carbon zero. So yes, we are working. It may take some time, but these are the challenges right now. And like what Mr. Partik has told, that cost is one of the barrier. But like in other countries, Oman and other places, once we will go with the indigenization of this thing, solar panels and other things, and some incentives like 40% duty is there on solar systems and other thing if we are importing from outside. Those type of issues are addresses. We are discussing even with ministry also. Can procurement of hydrogen equipment be brought under EPCG zero duty regime so that these become cheaper and hydrogen cost becomes further reduced? So a lot of initiatives are taking place. I think in next maximum 10 years, up to 2030, I don't see much scope for changing over to the hydrogen totally. But after 2030, definitely things will change because hydrogen is having a lot of advantage in steel making.
Understood. Thanks.
Mr. Mukesh, I want to add something. You are very right on your point. See, what we are thinking that any cost reduction, we can have two major impact. One is a scalability. Suppose the today hydrogen cost is not too much optimized because what scale we are utilizing it, 100, 200, 500 megawatt. Now let's see that suppose if we are doing it at a gigawatt scale, it can have a huge impact on it. Second point, I want to say that the technological advantage. So currently R&D and many other things has been going on in hydrogen since last so many years. But that R&D was not with so much emphasis because the stake of hydrogen is very low. Now when the whole world is just behind the hydrogen, they are giving good money to the electrolyzer developer companies. So they are also planning to evaluate different technologies, different options, which can give a better output with the reduced cost. So this type of way we can reduce the cost.
Understood. Just a follow-up, Mr. Prerak. So, as Mukesh rightly mentioned, there is no scope for, otherwise there is a very little scope for iron and steel sector to contribute in the GH2's demand for India's 5 MMT target by 2030. And if the demand just falls on the fertilizers and refinery sectors to adopt green hydrogen, and if you are mentioning that industries are not ready to adopt green hydrogen, like what can be done in the near term, in the next 4 to 5 years, to make them adopt it and get India to the target that they have mentioned?
No, what I told this thing, Sripad, that we are having like blast furnace route is there.
Yeah.
I'm saying 100% replacement is not possible. But
yes,
we should start injecting 10% hydrogen, 15% hydrogen. Even if we start injecting 10% hydrogen, the requirement of hydrogen in the steel sector is more than 2 to 3 million ton. Okay, what is our target of 5 million ton by 2030? And in 2030, steel sector has been given only 1.8 to 2 million ton only. Rest 3 million ton is going into the refinery and fertilizer and the e-mobility, because these are the areas where already established technologies are there. But iron and steel technology is there where we have to do the R&D also, and we have to optimize also. So that is my point was there. But definitely in our direct reduced iron making, in our blast furnace making, in our cold roll annealing systems, everywhere we are trying to use hydrogen, whether it is direct reduction, whether it is for annealing also. So those things are there. And every industry is taking that initiative. And I think it will help in reducing both.
Thanks, Mukesh, for the clarification. But to Mr. Prerak, the question still stands. For fertilizers and refineries to adopt that 15 to 20% or whatever mandate that they have suggested by 2030, if you are mentioning that the industrial readiness is not there till now, in the next 4 to 5 years, how are we going to make them adopt green hydrogen, even for that 15-20% intake?
Right. So the first step, we have to work on the electrolyzer technology. It's not that many companies in the India who are already having a good understanding of the green energy, they have already started working on an electrolyzer technology. Now, once the technology for the electrolyzer has been selected, finalized, we should make India as a hub for production of the electrolyzer. And then the hydrogen production would be a 12-month down the line process for it. I'm very much sure that 5 million metric ton per annum hydrogen production target by 2030 is an achievable target. That means it's close to 75 to 80 gigawatt of energy minimum we require to inject, which can be used to produce the hydrogen. In India, we are having two major benefits. Still, we are having a good land base where we can have a generation capacity for the combination of solar and wind, which is a hybrid project. Second, we have an excellent manpower strength, skill and unskill, which can be trained on the green hydrogen. Third, unlike some of the major countries, currently we are importing the major natural gas from the other countries. We have to import the fuel from the other countries. So we can consider green hydrogen as a self-sustainable base for us. Just like if we utilize the natural gas, in place of that, if we generate the hydrogen gas and utilize it, it would be a great saving on the import part. That can also be useful to us to manage our currency level compared to the other countries' currency. Second, import of the fuel. So currently we are discussing on the, just like many of the countries discussing on companies discussing on the hydrogen fuel based vehicles, truck and four-wheelers and all. That is a reforming factor that will change the industry once the hydrogen based fuel can come, because the more advantage of the hydrogen based fuel is that it could not take much time to do the fuel in the vehicles. So that means it's a time saving as well as it's cost saving part. Even if with a minor higher cost, if you are taking it, it can be a huge saving in terms of the excise and other duties. So this type of benefit government will give and the private sector will take the next step. I think that could be the best combination where we can fight and we can get the hydrogen successful.
Understood. Thanks for the detailed response, Mr. Britt.
Can I add?
Yes.
Government of India is also taking effort in the executing the pilot plants in terms of hydrogen valleys, where all these components, there are different components which contribute to the overall cost of hydrogen, including production and then supply chain and the end users, stakeholders. So pilot plants are being taken under Hydrogen Valley, the DST programs, to see wherever there is availability of water, wherever there is a low cost electricity available, wherever there are stakeholders available, like direct user of hydrogen. So there, these things will be executed and seen, and if become successful, some learning would be from there. They will be maybe scaled later.
Understood. Thanks, ma'am. Thanks for the input, ma'am. So just now to Dr. Guncha. So you have been working in the transportation sector and also you're looking at the green hydrogen as well. So again, based on the response from Mukesh ji, Prerak ji, it is clear that there needs to be some sort of readiness. And when the heavy mobility sector is considered, the nation is also clear on their thing. Its primary focus is on pilot projects of this mobility sector, and based on the success, they are planning for commercialization in the from phase 2, FY27 onwards. So what is your take? Because again, the technologies are already established, particularly from fuel cell vehicles point of view. So what is your take, and what India is doing currently regarding demand generation for green hydrogen? Is it the right way to go?
Well, thank you, Anirudh, for the question also. Maybe I'll talk about the fuel cell first, and then we can talk about what India is doing on increasing the demand side also, or what can be the steps which can be used for increasing the demand side, and what enabling frameworks can be done. So I'll talk about fuel cell first. Well, the challenges with fuel cells I'll categorize them into the three important points. First one is the cost. We all know that the fuel cell based hydrogen vehicles are costly or expensive in comparison to that of the conventional vehicles. So we have three fuel cell based hydrogen vehicles in place. One is Toyota Mirai, another one is Hyundai Nexo, and third one is Honda Clarity. So even if we get subsidies on hydrogen based fuel cell vehicle to purchase it, but purchasing hydrogen fuel in itself is a costly. So that has to be taken care while coming up with hydrogen based fuel cell vehicle. Another point is that hydrogen refilling station. We need to making hydrogen available to customers is also an important point. And hydrogen refilling station, we need a lot of hydrogen refilling station nearby, which and it needs a lot of regulations, code and standards in place, and obviously it needs technology development. The third important point with challenge with hydrogen-based fuel cell vehicle is the durability and reliability. It's just that it has to match up with the current durability and reliability has to match up with the current automobile engines, that is around 5,000 hours of lifetime, which comes around 150,000 miles, which is not achieved yet for hydrogen fuel cell vehicles. So that has to take place, because as the cost of maintenance increases, the total cost of ownership also increases, and nobody wants to spend a lot of money on maintenance rather than on purchasing. So these are the major issues which I feel is happening for fuel cell vehicles to come up. I'll come to your another question, that what enablers or what else government can do for developing green hydrogen scenario other than giving incentives on electrolyzer manufacturing. So I feel that, hydrogen being a very inflammable gas and a lot of safety aspects into around it. So maybe first one is a placement of a particular regulation codes and standards development, which will exactly tell the industries what are the standards which they are supposed to follow. So it will not only guide the technology development, but will also anchor the long-term investment. Now, another important point which I feel is that the simplification of the process of doing ease of business, which I think is very important. So once each and every industry will know what they are supposed to do, what are the process they are supposed to take when they have to follow the certain process or certain certifications and process, then they should also take. Then, as already we have talked about, research and development plays a very important role. So yeah, spending money on development of research and development in areas which require attention will be helpful in developing green hydrogen ecosystem by 2020.
Thanks. Thanks, Kuncha. So yes, based on the understanding on the industrial preparedness or industry's interest in taking green hydrogen, the reasons are pretty obvious. So one is currently there are a lot of R&D needed for the intake, and there needs to be a development of infrastructure to enable the intake. So with this, we will also talk some points from purely policy motivated perspective. So let me ask this question to Mr. Nishant. So again, like this has been mentioned already, like National Green Hydrogen Mission, to enable the demand for green hydrogen, they are currently mandating a certain % of green hydrogen uptake for fertilizers and refineries. For capital subsidy is planned to being offered for GH2 based products, and support for electrolyzer manufacturing is already there, and there is a robust RE procurement support for green hydrogen manufacturing. So will this be enough, Mr. Nishant, in your opinion, for a nation to reach our 2030 target? And like again, this was also pointed out by Mr. Prerak that 5 MMT is in fact a reachable target. So just to make it like a ease of achieving this target, or from even increasing our nation's target perspective, or this current supports given by government, is it enough?
Thank you, Anirudh, and good afternoon to everyone here. Thank you to WRI for organizing this. So what the government is doing is enough, but it's also not enough, right? For example, what the latest news that came out early this morning, the subsidies that are being given for green hydrogen production is only 90% to 85% of what the US is giving. Now, in the whole national green hydrogen policy, only around 10% is allocated towards R&D, or around 400 crores, I believe, or between R&D and pilots. Now, for India, our electrolyzer technology expertise or competence is not in par with so many other global countries. And this is something that we have to look hard at. We cannot do this alone. We have to partner with several other countries, also collaborate more effectively and efficiently within our own country, right? There are several institutions across the country that are working on green hydrogen technologies. We've come across 2 students who built an electrolyzer that doesn't need precious metals. And they've reached their 3rd round of funding, but nobody in the industry knows of them. Then there is Professor Ghosh in IIT Bombay, where L&T is sponsoring them to build electrolyzer technologies. Now, just like this, there are so many different pockets in the country that are, working on this. And I think what the government should do maybe in the next phase of the, a little bit later, is try and build a platform where all of this can be shared with the industry in a common platform. So that's one. Apart from that, I think the other important aspect is skilling. I think 600,000 jobs are expected to come into the sector by 2030 and about 3 million by 2050. Now, some of this project management, renewable energy experts, we do have them, but we are trying to build 150 gigawatts per year, I believe, if we need to reach 500 by 2030. Our current capacity is at 16 to 20 gigawatts of installations every year. So now that again requires almost a 5-fold to 7-fold increase for RE specialists. Now coming to electrolyzers, you need material specialists, you need electrical specialists. So skilling is a very, very important aspect, and the government will have to focus on it. Not only the government, but also the private sector. But what is really encouraging in India is that the private sector is doing a lot. And even just like what Dr. Mukesh was saying, several companies like his, they are making their own in-house, building their own in-house expertise and also building their own in-house facilities for RE production and green hydrogen production. So this will also help expedite. Now, what is crucial is the price of green hydrogen, like, our earlier speakers established. Once green hydrogen prices come below $2.5 a kg, things will start happening faster. And once it comes to 1.5, I think it becomes, commercially viable at refining. And then once it hits $1, we can completely get rid of city gas, use green hydrogen there. And there are so many other uses that will come in. And then the other challenges for more use is infrastructure development. And I think as we build more facilities in ports, build more facilities for mobility uses, I think things will expedite faster. I hope I've answered your question there.
Yes, Nishant. Thanks for the elaborate setting. You have mentioned the contributions from private sectors. I will come back to you on that. So currently, it is interesting that you have mentioned that once hydrogen hits that 2.5 and reaches that $1.5 per kg mark, then the city gas will be replaced. So when talking about city gas, CGD is also one of the priority area where they are focusing on in the phase 1 of the issue. So there are some concerns regarding the city gas distribution, particularly transporting hydrogen from point A to point B. There is this material embrittlement and all other things, concerns that are there. So how far do you need to modify the infrastructure to support hydrogen blending through city gas infrastructure?
Well, Anirudh, I'll have to confess that I'm no materials expert. I don't come from a scientific background, but from my knowledge, I do understand that there is technologies available, but we need to deploy this. There is a repurposing of pipelines that have been done successfully. And I also believe that there is a Center of Excellence for Hydrogen in IIT Delhi that was part of an India-Norway partnership. And they also have very impactful and effective information on such topics, where they also focus on safety. But I think the blending of city gas has already begun, I believe. And I believe NTPC is doing it. And, it's already begun. And this is why I say that, the government has done enough, but they've also not done enough. But as a country, we are resilient. And I truly believe that we will reach our targets by 2030.
Thanks, Nishant. So let me go back to Dr. Guncha. So yes, we have asked what kind of policy support is needed. Nishant was very elaborate in mentioning what needs to be done in addition to what is currently being done by the government. So, okay, enough from the government side. And how should the industries be prepared, particularly now that it is clearly established that steel will be focusing on one particular way, that's blending of hydrogen as a fuel, and then rest is up to refineries and fertilizers. So what kind of industrial preparedness is needed? What kind of things or what kind of techno-commercial shock that they must be expecting on adapting this green hydrogen?
Well, I believe that, these are my personal views that firstly, industry should be very sure that what they are looking for. If they want to take make out money from this, then they should know what their audience is or who the off-taker is for the green hydrogen or the green steel. For example, you'll understand, for example, if we are making green hydrogen in India and we are thinking that we'll export it, globally, then we have to look at the certification mechanism worldwide, which is again an important thing. Europe is saying something, US is saying something. So, these things have to be taken care if we want to do business out of the green hydrogen thing. We are looking at for R&D purposes, then we should look at the different technologies presently available and simultaneously keep on thinking that everyone talks about that once we achieve that scale, then only the cost of hydrogen will come down, which is very true. This is what happens with the renewables also. So, so if we are looking at the technology perspective or R&D purposes, whatever established is okay. But simultaneously, we should keep on thinking that what new can be done, which is scalable, and it can help us to come down the cost of that, because everything comes at the cost at the end of the day. Market is driven by cost only. So yeah, so these are my submissions.
Thanks, Kuncha. So now let's bring the focus to Sivaramakrishnan, sir. Sir, are you available, sir?
Yes, I am available.
Thanks, sir. So let me start with this particular thing. This National Hydrogen Mission is a massive undertaking. There is so much collaboration. Like there is some 16 or so ministries jointly taking this thing to achieve the target. And then there is also sector level decarbonization plans, and some states are willing to give their own green hydrogen policy targets. So like there are a lot of there are a lot of dependencies. So how to thread over this interdependence between ministries to have a very stable progress in achieving the target.
Thank you, Sripati, and good evening to one and all on this platform. As we all know, green hydrogen is expected to be a major technological avenue in bringing the emission reduction targets to a reality by 2050. In fact, 10% of the emission reductions are expected to come out from green hydrogen. GS2 is going to be a major contributor. Now, it is in this backdrop the National Hydrogen Mission was conceived, and further initiatives are being taken in the national and subnational levels. And let me expect to meet this target of 5 million tons by 2030. So let me explain you a few steps my home state has taken to address this issue. In fact, Kerala is one of the 10 states which is identified to have creation of hydrogen hubs for meeting the energy requirements. In Kerala we have refineries, we have fertilizer units, etc. So our requirements are quite high. Now, in line with that, we have conceived in a government level interministerial group is working towards this objective with our state nodal agency CEO, INERT's CEO, is the coordinator of this committee. Now, recently, let me explain two key policy drives which we have taken. One is in the industrial and commercial sector. The new Kerala industrial policy, among others, it has identified the renewable energy sector as a growth area and has announced incentives in the form of low interest rates, capital subsidies, etc. One of them is the exemption of electricity duty for the renewable energy, and there are top-up incentives of almost 20% of the capital investment, or rupees 1 crore, whichever is lower, is the incentive, top-up incentives offered to the MSME sector. We have around 2.3 million MSME units in the state, so they can take advantage of this. In fact, Kerala has got a very unique enabling system for the green hydrogen hubs. If implemented, once implemented, it could become one of the largest green hydrogen hub in Asia itself. So we have potentials for renewable energy in the form of floating solar PV, which we are now focusing. Kerala has a large water mass, and also we have identified offshore wind as another potential area to meet the green energy. Recently, we have, in fact, our nodal agency has signed an MOU with a Norwegian company to identify and start up some technology projects in offshore wind. So Kerala has a longer cost. So we are hopefully working towards meeting the targets. We have a potential of almost 9.5 gigawatt of power in these sectors. And we have fortunately very high demand sectors for hydrogen consumption, like refinery, fertilizers, chemical industries. And another major solution is the mobility solution, such as electrical vehicles. And fortunately, we also have the water metro system, which can run in electric power, because Kerala has got a very vast inland waterways within the state. And we also have a very strong infrastructure, green infrastructure, such as natural gas and LPG pipelines, where a green hydrogen can be blended for supply to the consumers. So all these are giving us hope that we can have green hydrogen hubs. And in line with the Green Valley concept of Department of Science and Technology, we have identified Cochin and Trivandrum to be the major valleys, two valleys for implementations. And with that, we hope to achieve our own committed. Our state has committed RE100 by 2040, and we also have committed the net carbon neutrality by 2050. In fact, the Cochin hub of green hydrogen is jointly being implemented by Indian Hydrogen Alliance and the government of Kerala. We expect to put up around 60 tons a day capacity there with 150 megawatt electrolyzer capacity at an expense of approximately $575 million. And this first phase, this is the first phase, and we expect that this will be met for the mobility sector. It will be only in the second phase that we will be taking up the requirements for the refinery and fertilizer sector. In fact, yeah, I will cut short. Give me one more minute.
Yes, sir.
Because I have to also speak about a much important policy called the hydrogen policy, green hydrogen policy, which Kerala is now coming up with. It's in the draft stage, but there are many incentives announced there. It also there are fiscal and non-fiscal incentives announced there in the form of say open access for renewable energy power, and 50% exemption for wheeling charges, and 50% exemption in the intrastate transmission system. And there are 100%. That is, if that happens, really, it will be wonderful. But because 100% exemption from cross subsidy is also being scheduled. So with all that, and another initiative is the banking facility. We propose to be 30 days. And with the special banking charges, so that the electricity cost can be brought down for the, that was the major worrying point Mukeshji has been mentioning. So we are also focusing on wastelands, and approximately, as I mentioned, around 6 megawatt is going to be developed from this, and we plan 3 megawatt by 2027. And also we have budgetary supports in our recent budgets. We announced rupees 1,000 crore for land acquisition for activities developing in the green hydrogen hub in the southern district of Trivandrum, Vizhinjam Port. To be exactly, it is one of the identified areas for hydrogen fueling station in future. And we also have 300 crore in the budgetary support allowed for development activity. So these are the key initiatives. I think with Mukeshji himself was initially mentioning that the steel may remain in the hard to abate list for some more time, but at the end he himself said if the way it proceeds now, 2030 could be a realistic target date. So I think these are the initiatives from our side, policy initiatives. Back to Sripati.
Thanks. Thanks, sir. Thanks. That is indeed a very elaborate explanation, and happy to know that Kerala is planning for a full-fledged hydrogen policy mission, as well as targeting net zero by 2050. So happy to know I will circle back to Nishant regarding the private investment. So India has attracted a huge private investment in the RE sector. And currently, like what is the state of investments for the nation compared to the global level? And how much investment will be needed for India from the private sector to reach the target?
Thank you. Thank you, Shripati. I think the MNRE has visualized around 70% of the required investments coming from the private sector. What is important here is looking at innovative ways of financing these projects, where we use mechanisms that are blended. This new concept called blended finance has come about, where you use subsidies and grants and combine it with different financial products to enable infrastructure and capacity building for green hydrogen. The other challenges here, even the private sector is facing, is there is no price index and spot markets for green hydrogen. So some of these contracts and most of these financial organizations are hesitant to come and finance these projects. But ultimately, I think around $500 billion would be required for us in the next 5 to 6 years to get where we need to be. I think it's around 8 trillion rupees, if I'm not wrong. So the challenges are there. And I also want to touch upon two other comments made by panelists earlier. One is Dr. Gunchal, who mentioned about international standards and certifications. And this is something that we as an organization have been doing since early 2021. And we build our own standards much before the ISO thought about it. And now over time, we are aligning ourselves with different standards that are coming across in Australia, in the EU, in the USA. And we've also just had a brief discussion with the MNRE last week when our CEO was here. So we aim to help harmonize all of these standards that are coming across the world. So we will give you a certificate that would let you know that, hey, this production method is certified to be exported to the EU, or this is, this is good for Australia and this is good for Japan or Korea. And this is something we're doing. And there's another question in the panel by Anup Babu, and he raised an important point on grid feasibility and how much the grid can take. Because note that we've only hit the highest installation of RE capacity last year at about 20 to 16 gigawatts, and we are envisaging 150. So we have a lot of work to do on the grid as well. And this is a very important factor. And I think there was notifications from the MNRE. They asked, I think they issued some notification about using pumped hydro storage, but that will just, help stabilize the grid. But expanding the grid, studying the grid to handle this huge spike in renewable energy capacity is also a very, very important challenge as we look to scale.
Understood. Yes, thanks, Nishant. So yes, so we have come to the final question. So this is just an open question regarding some of the challenges. As mentioned by Nishant, there is this 150 gigawatt that needs to be integrated, particularly for use of hydrogen. And then as Prerak initially mentioned, there is a huge water requirement. So there is an estimate that over 50 billion liters of water is needed for this 5 MT per annum target by 2030. So it's just open to all panel members. If you can address like one important point that needs to be addressed. It's not only focused on green hydrogen production, and there is a lot of value chain left behind. There is storage, there is transportation of hydrogen, and there are some industries which can use hydrogen, like marine industry, fuels, and other things. So if each panel member, they can just share their views on what are like the one primary change that needs to be done for the easier enablement. So let's start with Dr. Pooja Devi. And ma'am, if you can also share some insights on seawater electrolysis and those kind of aspects, that would be helpful.
Yeah, thank you, Anirudh. So yeah, you rightly said, so it's not only the, electricity, the electrolyzer technology, basically the water intake is also an important factor. And for a country like ours, which is your developing countries, is a developing country, and also we also face at several states the water stress. Also in several states we are facing those issues. That's also an important thing we need to look for when we are talking about like establishing hydrogen hubs in different parts of the country. So definitely government is looking into this particular aspect also. So not only demineralized water, which is generally used in the electrolyzer technology, the other low quality water, including the sea water, is being looked upon. But there are challenges in using these waters. Like if you talk about a demineralized water based technology of electrolyzers, which operate at a like current density of 1000 to 1500 milliamps. When you use sea water or a low grade water, it dropped down to very lows, up to maybe 500 milliamps to 10 milliamps, depending upon what is the kind of water which is given as a feedstock. So there are work being done in terms of either developing technology which can use these low quality water as a feedstock directly, or pre-treat these water and then use that as a feedstock in the electrolyzer. So CSR is also executing several research projects in this domain to use seawater as well as low quality water, like the water generated by wastewater generated by different industries. Yeah, so that's all from my side.
Thanks, ma'am. Mr. Nishant, you are on mute. You are still on mute, Mr. Nishant. Yeah.
Okay, should be good now.
Yeah, it should be good. Yeah. Yes, Nishant. Just one key challenge that needs to be addressed.
One key challenge that needs to be addressed.
Yes, you were
one key challenge, but there is a whole, there is a
bunch,
slew of them. But I think we have the capacity as a nation to focus on each of them individually. And I think most of our challenges have been addressed, but I think we need to look. I like something Dr. Kunchal spoke earlier is cost, right? We first need to focus on bringing the cost down, because once the economic incentives are available and feasible, the industry will kick off. And I think we need to focus on what can move us forward. And if we can focus on the next step that will take us forward, we will address all the challenges that come one by one. So that's how I want to answer this question.
Thanks. So going back to Mr. Mukeshji, so like even for that utilization of hydrogen as a fuel for blending purposes, you may be needing a steady storage infrastructure, right? Will that storage infrastructure be possible, like based on the current development, R&D development in the storage space? Will that be possible for a steel sector to include that for their 1.8 million tons of hydrogen demand development or whatever?
As I mentioned, because the biggest problem with the hydrogen is the RTC power. Because today, if you see round the clock power is not available. And a lot of people, this is the biggest challenge we are having. Whether we call it a pump hydro, whether we call it a fuel cell, battery, anything we take, but this system yet to be developed. And if we have to generate hydrogen continuously, then we require RTC. Now, you have asked about the storage, because transportation and storage of hydrogen is a big issue. If you want to, because hydrogen is the lightest gas, but in terms of the gas, it does not have any heating value or anything, unless it is converted into mass. And when you convert into mass, you require liquefaction, means a pressure of around 600 bar or 700 bar, and a temperature of around minus 250 or 260 degree temperature. So that technology is also a big challenge. That's why what industry is doing, hydrogen industry, wherever any hydrogen is there, they want to see that this type of capital investment is avoided. Today, we are in a position to produce what $2.5. But when you come to the transportation and the storage, it will add a lot. It will require massive infrastructure change. And that change is not that easy. All cryogenic transportation, any gas you can transfer, liquefied natural gas and other things, but that does not need that type of thing. So that's why what we are trying to do is that try to develop hydrogen near the end consumer.
Understood.
And then we can take it.
Yes, sir. Thanks, sir. One last question to Mr. Sivaramakrishnan. So considering Kerala's 2050 net zero commitment and RE 100 by 40. So offshore is going to be it's going to play some huge part in the RE mix. So from a general sense, cost of RE is high, electrolysis cost is high, so green hydrogen cost from those power will also be high. Like, how are you going to enable the offshore power intake for the green hydrogen purpose?
Sure, that's a very genuine question. Offshore power is going to be costly affair, no doubt about that. But the biggest challenge is to provide a low-cost renewable energy. In India, in the first phase of the green energy corridor, we focused the 8 RE-rich states in the country. This has not been extended to other states right as of now, but in the phase 2, there are expansion plans towards other states also considered. So this earlier completion of this green energy corridor is, according to me, is a great challenge. And unless that corridor reaches each and every corner of the country, you will not get a RTC power or a low-cost RE power. That is one part. I'm sure your question is genuine. Offshore power cannot meet. And as of now, probably as the technology matures and grows, probably in future, it may happen. But right now, we are depending on green energy corridor to come to every part of the country.
Thanks, sir. So we are running out of time, so I have to limit our interaction from now. I hope the discussion was fruitful for the participants as well as, like, I know we just barely scratched the surface. At least hope that the scratch is good one. So let me give this control back to Abhishek. Thanks everyone. Thanks,
Sripati. Thanks to all the panelists for that wonderful discussion. I think we all have takeaways from this particular session with all these esteemed panelists. I think now we have reached to the last part of this session. I would like to call upon Vaisak Kumar, to provide his closing remarks. Thank you, everyone.
Hi, thanks, Abhishek. I hope you're able to see and hear me. Yeah. Yeah, great. So first of all, I would start by thanking all the participants for joining in and being a part of the session. Also, a big thank you to all the presenters for setting the context for the discussion, and also to the panelists and the moderator for bringing out key points on the topic. So taking view of the time, I would conclude by making 3 to 4 key points. So I would say about the 3 to 4 key highlights from the session. So we saw that using green hydrogen in the steel production process is possible, but as of now, this requires more power and tends to be more costly. Hence, more R&D efforts are needed in this area. And also, we saw that the cost of green hydrogen is still a concern, and more R&D efforts are needed to bring down these costs further. Also, we saw some points where we discussed that the electrolyzer technology is still new and has not yet been proven on a large scale, and also more work needs to be focused on this area. Also, we saw that green hydrogen can help where, it can help like in where it can be used in place of natural gas, and it can get us to more self-sufficiency. Also, when we also talked briefly about fuel cell-based transportation. We saw that currently the cost of ownership is more due to different factors, and this needs to be brought down for it to be more popular. Also, some of the key other points that were made is that skilling in this sector is important. And it would be great if we can have like a platform where different R&D activities are showcased, which can be then taken to the industry. And also towards the end, we also saw that more work needs to be carried out on the grid as well. So I guess, a lot more key points were discussed, but I guess I was able to capture a few of the main ones. So with that, I would like to once more thank all of you for participating, and that's it. Back to you, Abhishek. So I guess we need to turn on our cameras once so that we can take a group photo. So
yeah,
I
would request the panelists to just switch on their cameras for a group photograph. Almas, would you be doing this, taking the photograph?
I'm trying to Is the gallery for everyone visible the same? Everyone can see everyone?
Yeah, I think everyone can see everyone right now.
Awesome. Got it. Thank you.
Thank you, everyone.
Thank you.
Thank you,
Have
everyone.
a good
evening. Take care. Thank you. Bye-bye.
Thank you, everyone.
Thank you.
Goodbye.